All right. This is Math 238, Applied Differential Equations. Last time we had a very short session, and I rushed through the syllabus. If anyone has any questions about the syllabus, please let me know. I'll go over that with you if you have any questions. What I rushed through wasn't updated, so I'm going to update that syllabus hopefully this week, but no promises there, and then move on from there. We also pretty rushed through, I think, the research paper instructions. If you have any questions on that, again, please see me. I'll get those corrected and put on Blackboard as well. Neither the syllabus nor research paper instructions are on Blackboard yet, but I'll get them there as soon as I get the updates made. Now, so where we left off, now I don't have my locator card done yet. When I get that done, I'll flash it up at some point and go over it, but it's pretty straightforward. So the one last thing that I wanted to do today was ISBN. All right, the one last thing to do before we actually get into the course is safety. And both of the students in the class now were in at least two classes last time. So I don't think I got safety done in this class at all because we were running out of time quickly. So let me go over safety. There's three issues of safety that we deal with, okay? The first of these is, something wrong? The first of these is weather. In other words, some external thing. If we hear that alarm go off, that the severe weather is upon us, then the main thing to remember, y'all have been in it, the two people here have heard this several times from me, but I'm doing this for the people not here, is to go low interior, okay? And what we mean by that, you leave our classroom here, take an immediate left, go down that half flight of stairs, take another immediate left, go down another flight of stairs until you're very close to the lowest point of the first floor. All right, now, where are the safest places to be there? Actually, safety-wise, the restrooms are pretty safe because the walls are close together and you got a lot of corners in them. That's your greatest strength in a building, the corners and close walls. But usually restrooms are the most desirable places to spend a couple of hours if it's a really serious weather event. And if it is a really serious weather event, there's a real good chance that our power will be cut off. And in the restrooms, that means no ventilation and no lights. So again, not the prime place probably you want to spend a couple of hours. So after that, if you go out of the restrooms and down, it's just a couple of more steps. Immediately on your right is a room, I think it's 158, I believe is the number. And that room is the dean's and associate dean's office here on the Bessemer campus. If they happen, either one of them happens to be in and that room's open, and they don't mind you coming in, you can ask, and if not, it's a fairly safe room too because, again, it's interior, that's the big thing, but it's also fairly small, so the walls are close together and lots of corners in there, okay? Now, if not there, the next best would be the hallway, okay? The hallway, there's no corners, so you lose that kind of strength, but the walls are relatively close together. The good news about the hallway is it has emergency lighting, whereas even the dean's office probably does not. So dean's office, you'd be in the dark there, except there's open door and glass door, so you could get some light from the hall. But the hallway would be okay. I would say stay close to the wall, though, okay? Middle of the hall is not as good as near the wall. Now, if all those spaces along the walls are occupied, you can go down to the next room, and that's room 160. That's a developmental math classroom. It's a pretty big open space, except it's interior, and there are at least 4 corners in there, and there are walls. So if the corners would be best, the walls would be second best. I wouldn't stay in the middle of the room, okay? Go to along the wall. No emergency lighting in there, so you might want to stay fairly close to the door if you don't like being in pitch black, okay? Then you could go into the library area, but I wouldn't go far. The first room in the library area is their computer room. That's a little bit smaller room, so it has some more corners. 4 corners, but the walls are a little bit closer together, so along the corners of walls, that would be good there too. The very next room is your reference room. What did you call it yesterday? Archive room. Is that what you called it? Yeah.
I don't know if that's accurate.
Yeah, whatever it's called. But it's where the atlases and globes and those kinds of things. Typically, books not for checkout, but it's an interior room, and it's not a huge room, so it's probably relatively safe. But I would not go any further into the library, because then you're on an exterior wall where there's glass. You could get injured. So those would be the best places to go for a weather emergency. Stay together as a group, because, and I mentioned this in one class, but I didn't get to do it in all the classes yesterday. If there's someone, and in fact in my last class, the first class this morning, I had a student in there who is mobility impaired. She has pretty serious crutches, and so if that were to be the case, like if someone's had an accident or twisted an ankle or broken a leg or something like that and has some limitations of mobility, I'm going to be making sure that person safely gets down the stairs into the safe area. So I probably should be the last person down there. So stay together as a group. Wherever you decide to go to, don't go to the restrooms yet. Stay together as a group, and when I get down there, I'll call roll again. We make sure everybody's accounted for, and then if you want to go visit with friends and stuff like that, as long as you stay in the safe space, that's okay. But we stay together as a group, because if you wandered off somewhere and decided to go your own way, then no one knows whether you were stuck in a classroom, you fell downstairs, you went to the restroom and didn't come out. We don't know, and emergency rescue people will be risking their lives trying to locate you. So stay together until we get a full accounting of everybody. All right, that's weather emergency. Any questions on that?
Usually they send out a cougar alert most of the time. Last year at least, I didn't have to deal with any of that.
Now, what's this again?
The cougar alerts save us some trouble.
Oh, yeah. The cougar alert. If you're not on campus, the cougar alert will let you know. And even if you're on campus, you'll get the message. But then,
like they'll cancel school completely some days.
Right. But even if they cancel school on the weather emergency, don't get in the car and go until you've gotten all clear, because highway's the last place you want to be in a tornado or a severe weather situation. Even that flooding they had down in Louisiana, cars were being swept wherever the water wanted to take them. So not a good thing to be in. All right, that's weather. Any other questions on weather? Okay, the number 2, the second thing is, what if the emergency is coming from inside the building? This could be fire, chemical spill, that kind of stuff. What do we do then? Now you go down and out, not down and in, okay? So we go out of the classroom. Okay, time out. Let's back up a little bit. What if the fire initiated in this fan room right next to us, and we're the first ones to detect that there's a burning smell, smoke coming out, something like this? What's one of the first things we do?
Fire alarm.
Find the closest fire alarm. Now, for those who are not familiar with this old building, this part we're in is the oldest part of the building, okay? And all this part, the hallways are the terrazzo floors. Any of those hallways, don't bother looking for a fire alarm. There aren't any, okay? you have to go down to the newer. This part was built before that was required by code, so it's the newer part of the building, which is where financial services, student services, bookstore, those kind of areas. Pictures here. That's where you'll find the closest fire extinguisher. So I'd say 2 people. I don't want to send one by him or herself, but if that's all we got, that's what we got. Go down this half flight of stairs, go to the corridor that connects, goes over to financial services, go through there. When you get into that new hall, look on the walls for the closest fire extinguisher. Pull the fire extinguisher, then come back, and hopefully by that time, the rest of us are down the half flight of stairs and on our way out of the building. Join us and get out of the building. This first stairwell at the base of this half flight of stairs, go down there, and typically they say about 75 feet away from the building. The reason you get away from the building, you're not trying to get in the lee of the building, because if there is a fire, that could lead to an explosion. With an explosion, then you have glass going outward. You want to get out of the range of that. So, go down and out. Now, what if the fire actually were in this room? Can't imagine there much. All I said last day, my pile of papers spontaneously combust. What would you do then? Besides somebody going to a fire alarm, somebody else goes to get the fire extinguisher. Now, if you don't want to mess with it, don't sweat it. Go get it for me. I'll deal with the fire extinguisher. I don't want you getting too close to the fire to get burned. But the rest are heading out of the building. And again, when you head out of the building, you stay together as a group. You don't say, "Hey, no chance of school happening today. I'm out of here." No, you stay together as a group, because I'll come down. I'll probably be the last one out there. Come down, find the group, take roll again, and if we can't account for everybody, then some emergency rescue person has to go into the burning building where there may be explosions and stuff going on, risking his or her life trying to find you who took off in your car when you weren't supposed to. So please stay together until we get official word of what to do next. Okay? But let's go back to the case of what if the fire actually started in this room. Someone would get the fire extinguisher. It's just outside the door, within 4 feet of this doorway. There is the closest fire extinguisher. You can't get much closer than that. Bring it in here. I will douse the fire with it if I can. If I'm injured or something like that, somebody take responsibility to do that, and the rest of you head out of the building after someone's done the fire alarm. Again, stay together as a group, and we will take care. And again, I will be helping anyone who does need help getting out of the building. Okay, that's fire or chemical something interior. We get out. Don't leave until you're told what to do. Okay. What's the third emergency situation? And this came home yesterday afternoon late. I was down on the, asking the dean a question. She was on the help desk. And she had a phone call come in, and she was trying to help a student, and she said, "Oh, your department chair is right here." She handed the phone to me. It was one of my adjunct math instructors, and this was already close to, I think it was after 5 o'clock. And this instructor is a teacher at, I think, elementary or junior high or something like that. I think it was junior high. I'm not sure. It could be high school. But she was an instructor. She said, "I can't make my 5:30 class this evening. We are locked down." And she said they had a shooting. I said, "At your school?" She said, "No, it was just adjacent to the school, or something very close to the school, and they locked down the school because they didn't know who was doing the shooting, but actually one child was killed." And I don't know what school it was. I didn't hear the news last night. I don't know if any of you heard. Yeah, but she said a child was killed, and so they were in a lockdown. So if that were to happen here, hopefully it won't, but it's happened on a community college already, a year or two ago, and normally we're pretty safe places. I think we are a very safe place, but if you'll hear it before I will, I'm hard of hearing. If you hear something that could be gunshots, what do we do? Okay, if any of you have a phone, we used to have a phone in that office there, and we dial 1. It's not there anymore. Okay, so if any of you have a cell phone, which most of you do, and you don't have our campus police on your speed dial, if you have them, call them immediately. If you don't have them, dial 911. Okay, because there's no time to be looking up numbers. Dial 911. And then there is a posting there. We can find the number for the police and let someone know here. Okay, so yes, we do that. Good. What then do you think another first activity would be? And by the way, that same thing goes for smoke coming in the room or a fire in the room. We also dial, I forgot to say that, we dial campus police, okay? And probably if we don't have that number, 911. If it looks like it's going to be a fire, they need to know. So we don't have the facility to fight it, they do. So, forgot to say that. Okay, what next? What do we do as a class?
Get away from the doors.
Very good. Let me go over what I will be doing. Now, some of this is going to be cut off. I'll move around when the people are here. Victor, have you heard all this before? You have, haven't you? Okay. Doing it mostly for that guy who hasn't been here before. Okay. Rena, I think, has heard it too. What I will do, this door from the outside is unlocked. The only way to lock it from the outside is for me to go outside and physically lock it, the thing, and then come in and pull the door too. I will do that. I have the key. I can do it. Y'all stay away from the door. Okay? Now, they can still get in the next door. I cannot lock the next classroom door. Okay? I can lock this door. This door is a lot easier. There's just a button on it. But the thing is, you don't want to lock that door. Anyone know why? Okay, I'll demonstrate it for you. That one I have to go outside to physically lock. Yeah, the thing is, when I press this button, you're locked in, but someone else can get in here. So no, that's not a good idea on this door because it's locked in the wrong direction. This door requires a key that I don't have. I've tried all my keys and it doesn't work. Okay, they don't work. So there's no way to lock that. This door here has a button right here, and when I lock that, it's locked from this side, so we can get out.
So that big door.
That would be the door to lock.
And then probably just close the middle door anyway.
What's that?
And then close the middle door.
And then close the middle door, and why that?
So they can't see.
Because they can see in there. Closing this door is locked. That one's locked. This one's locked, but they can't see in. So I would close this one too, but not lock it. Okay. Now, so I've got that door locked. I've got the third door locked. That door closed. This door doesn't matter. I can go and close it anyway. Where do y'all go? Right, the safest place is right back here behind Ashley. Okay, because here he can see in. There, if this one did get locked, he can see in. I say he, most of the time it's been he. I don't know if there's been any active shooters who were women, but whatever. He can fire through the door here, fire through doors there. Kind of hard to fire through. Tile wall, concrete block wall. That's going to be our safest bet. Right in that corner, he can't see us, and probably doesn't have the firepower. If he has the firepower to go through that and he shoots from there, he's going to get more injured than we would. Okay, because the blast will come back and things will be slanging on him. So that's what we do, and we stay still, quiet, and in place until we are absolutely certain we've got the word situation is under control.
Also, probably turn off the lights and stuff.
Yeah, that would be a good idea too, and that way he thinks no one's in the room, so he won't even try to bust down the door. The bad news for that situation is, once he breaks the glass of that door, he can reach his hand through and open that one. So then we're in trouble. Okay, but there's not much.
If we hear that door being
broken
it's
into,
time to go from hiding to fighting.
yeah. And then we go down that hallway and get out of the building as soon as possible, I would say. But anyway, hopefully that will never happen. But they want you thinking, okay? And of course, we've dialed 911 and all that kind of stuff too. All right, any questions on any of our emergency procedures? And the important thing, stay together as a group. You know, we need to account for everybody, even in that situation. That way, we are going to be in a group. What's that?
I was double checking with him that we went over the paper yesterday.
Right. Okay. All right. Good deal. Okay. Then I guess we're ready for actual math. What a surprise.
What?
Okay.
What is that stuff?
Yeah.
Well, this class was syllabus class.
Yeah. Now, I think we talked about the book and everything else. I don't know if any of you have it. Is there anyone with it? Not yet? Okay. I'll try to, now, there's
I'll probably have it by next week.
a bad thing about the book is there are no PowerPoints. So I can't put PowerPoints out there on Blackboard for you. I don't have any. So I will be teaching from, this is running, isn't it? Recorder is recording, that's good. Don't want to pause. Okay. I've got to see how to get my screen to come up, to write on. You're supposed to be able to do that. Say again?
The little X in the middle bit. This one here.
Okay.
What's that?
Let's see. Say again? Where would you say?
This. No. What is that? Task.
Task. That might be it. Right. No, don't think so.
I don't think so either.
No.
Didn't you used to just like pull up a blank PowerPoint page?
Yeah, but that was integrity.
Yeah.
Um,
I mean, as long as it's a blank page you can write on, you can activate your pen through your computer, right?
I guess it's activated. Let's see. But see, that was all part of integrity.
Pen's built into the laptop, so if you maybe opened a Word document or something.
Yeah, that's what I was going to try here. Is Word, I guess. Don't know how this is going to go. Let's see what happens here. Well, there it comes. All right. Blank document. Okay.
Full screen probably would be useful there. Not that one, the one below it.
Oh. Okay.
Let's see if you can write on it.
Let's see. Not that I can. Wait. Let's see.
Something. There you go. Nope. Okay.
Still not.
Writing pad. That looks to be your writing pad here.
What's that?
This yellow thing looks to be your writing pad.
Oh, what? This right here?
Mm-hmm.
Okay. Can I expand that?
Try using your cursor.
Yeah.
Right.
Okay.
So, can we increase the size of this thing? 'Cause if not, that's going to be sad.
We've already hit this one.
Yeah, that's just activating the writing pad.
This is real good.
Yeah. It's not good at all. Wait a second. Let me see something. Close out this and just that for now. Accessories. If you have paint, that'll probably work.
Paint is right there.
Yeah. But will it work with the pen?
Excuse me.
Alright.
Full screen.
Mm-hmm. Alright.
Can I get it? I can maybe pull this way.
Yeah. Yeah.
All right. Let's see if this works. Hey, it does.
Awesome.
All right. Thanks.
Paint is going to be your new friend.
I am afraid so.
And,
All right. Let's talk about the book a little bit. I did some things last time. The first chapter in the book, probably a pretty good thing to look at. And by the way, they have these little projects and things like this. They look pretty good, and it sure jumps right into some pretty heavy statistics and that kind of stuff. But it's up to you whether you want to read that or not. It goes on and on and on. Is this? Well, y'all don't have the book. This may only be in the instructor edition. This is really
different color page.
Yeah.
It might be just here.
I'm guessing it's mine, so I'm just going to move on here. Thinking I'm going to get out of it. There we go. All right, here's chapter 1. And again, I had not planned to do this, so it's Introduction to Differential Equations. It's well worth the read, okay? And maybe since y'all don't have your books yet, maybe I should go over it, especially since not everybody's here. So 1.1, yeah, I think I must have gone over this before. I don't think there's enough here that's going to be tested about per se. We might just combine chapters 1 and 2 for testing. I think let's just say chapter 1 is just background material. If I find something that's worth testing, I'll let you know. First, the definition here. The equation that we back up here. Let me start with the introduction. Let me find an eraser here. Surely there's got to be an eraser.
Yeah. Click the, see the little...
Oh, there it is. There it is. I see it. Okay. Thank you.
And you
Okay.
pick different colors and everything.
Right.
And actually, there's a way to get graph paper on there. I have a feeling. So.
Yeah, we'll try that too. All right. If you've got a book, chapter 1, section 1.1, the title of it is Definitions and Terminology. Probably a good idea to go and do that. Now, we say differential equations. When you hear differential, what do you think of? Okay, differentiate. Very good. Which comes from what? What does that remind you of? Derivative, exactly. Here's how we express a derivative. Whoa, this is awfully light. Okay?
Go to the size. You see the size over there to the right?
Yeah, okay. And let's do this one. Okay. Is that okay? Do you read that fine?
I would say go up size.
One more? Okay. This one. Okay. Let me go back and erase this. Boy, you have to do a lot more scrubbing to get it to erase. Okay. dy dx. That, hopefully, all of you think Derivative, right? That's what that stands for. Derivative of a function, and if your function is y is equal to some function phi of x, okay? This is a function. Y is equal to phi of x. The derivative is also typically going to be a function, okay? And we would call that dy of x. If y is this, then dy dx would then be phi prime of x. Or we sometimes call it d phi dx, okay? All those mean the same thing if this is your function, y is a function of x. Here they're using phi rather than f. Don't know exactly why. Here's a function, specifical. Y is equal to e to the 0.1. I can't read that. I think it's x squared, okay? The exponent is so small I can hardly tell it. Now, number one, answer me this. Is that a differentiable function? Yeah, it is. Exponentials are differentiable functions. How would we differentiate that? What would be your dy dx? Yes, that's in there. E to the 0.1 x squared. That's there. But what else is there?
It would be 0.2x.
Yes, times the 0.2x. We just used the chain rule, right? Okay. So this is, believe it or not, a differential equation. dy dx is equal to 0.2x e to the minus 0.1 x squared. Okay? Now, okay. Here's something else they're going to do. Notice what this part is here. That is your y, isn't it? So you could have also written this differential equation as dy dx is equal to 0.2x y. There's a differential equation. Okay? Now, if that's where you started and said solve this thing, could be what? How? Why? I mean, where does this come from? So that's what this course is about. How to take an equation such as that and find the solutions to it. Okay? Easy when you're starting with the function and going this way, and we see how that works.
Harder going
And how, harder going backwards. Okay? So, definition. The equation you made up here, that one right there, is a differential equation. It has a differential in it. Now, actually, when I see the term differential, I think dy dx. So I think this. dy is equal to 0.2x y dx. To me, when I think the word differential, I think this. But differential equations are often written. Really, it seems like they should be called derivative equations. But they call them differential equations. Because to me, but guess what? They're really the same thing. Okay? So that's what a differential equation is. But most of the time, it's going to look like the one there. An equation containing the derivatives of one or more unknown functions or dependent variables with respect to one or more independent variables is said to be a differential equation. So I think now, I wish this had an erase all, but do you know where that is? The bucket?
The bucket right next to the pen.
Right there.
Yep. And then switch to.
It says fill with color.
Yeah. Pick white.
Oh, ha, clever, huh?
If you go over to the right, that's your color selection.
Oh, there it goes.
Tap anywhere on the screen. Oh, wait.
Just anywhere else on this.
Do switch your color 1 to white.
Oh, I see. No.
Well, let's see. Select all, and then maybe.
No, help anywhere in it.
No, that didn't help either, did it?
It doesn't.
Maybe just new, and then don't save. Just do a new one each time.
Okay. All righty. Okay.
Maybe just temporary fix.
All right.
It'll work
For now, yeah. So let's go back to the pen. I'm going to have to figure out what all these tools stand for, but I'll get that later. An equation containing the derivatives. I'll abbreviate like crazy. The derivatives, okay, of one or more. I'm going to put 1 plus after a while, okay? Unknown functions. That's functions. Or dependent variables. Okay? With respect to, WRT is with respect to, one or more, 1 plus, that's going to be 1 or more, independent variables. Okay, is a DiffEq, okay, differential equation. And you'll hear people talk about this as DiffEq, differential equation, okay? That's what they mean. And they'll abbreviate it quite often as a DE. Now, later we'll add some more letters to that DE, and we'll get there. To talk about them, we classify differential equations according to type, order, and linearity. 3 different classifications, okay? Now the type, okay? All right. Where did you do this, the upper left? You. Huh? Close this.
Click new again. You may have to do it with the mouse. Yeah, you have to do it with the mouse.
Oh, okay. This is real handy. I'm glad it's here. Sorry, I'm still learning Screencast-O-Matic. It's got to be better than this. Okay. New. Don't save. I hope Screencast-O-Matic is saving it all, so I hope. Okay. So, let's first do type. Okay, types of differential equations. Okay. If a differential equation contains only ordinary derivatives of one or more unknown functions with respect to a single variable. Okay, I better write some of this down. Okay, if the DE, the differential equation, contains only ordinary derivatives, oh man. Now I'm realizing why this follows Cal 3. Okay? Because right now all you've ever done are ordinary derivatives. Right? In Cal 3 we will be learning partial derivatives. Okay. So don't worry about partial differential equations. We're not going to do any. That's not covered in this course. But this is you've probably not even heard the word before, but we're only going to be doing ordinary differential equations. Okay. So this distinction here, don't sweat it. We're only going to do this first kind. Only ordinary derivatives, okay, of one or more, one plus unknown functions, okay, with respect to WRT, with respect to a single independent variables. Okay? Then this is said to be an ordinary differential equation called an ODE. The ode to math. Okay, no. Now, an equation involving partial derivatives of one or more unknown functions with two or more independent variables is called a partial differential equation. We will not be doing any partial differential equations in this course. I'll show you one in just a second, but we're not going to do any. Okay, that usually is a separate course. I had ordinary differential equations my sophomore year. Partial differential equations was a senior course, senior/graduate course. Okay, so you don't expect to see any here. I'll show you some. You'll do a partial derivatives in Cal 3, but we're not going to do any partial differential equations. Okay, that's a completely new ball of wax. So here's an example. dy dx, there's your derivative, with respect to one variable, x. Independent variable x, y is your dependent variable. Plus 5y is equal to e to the x. There is an differential equation. Has a derivative in it, an equation, has other variables. This is your dependent variable. Here's your independent variable. You have other functions of the independent variable, the function itself, but only one independent variable. Okay? Here's another one. Okay? d2y. We've done those, right? Or not? Is this also a Cal 3 thing? Y'all didn't do second derivatives. Yes, you did. Of course you did. Okay, yeah. Okay. Yeah. d2y dx squared.
You could write that as like y double.
Yeah, exactly. dy dx plus 6y equals 0. That's an ordinary ordinary differential equation because all of these are ordinary derivatives. One single independent variable. Y is a dependent variable, okay? Not an independent. Y is a function, actually, okay?
And I think you can actually change the eraser size just for future reference.
Okay, the eraser size.
Yeah, you know how you had to do a lot of
Yeah.
if you tap the eraser.
Right. Let me finish this and then we'll do it, okay? Okay, yeah, I'm going to do this last one, but it's pretty simple. dx dt plus dy dt is equal to 2x plus y. Now you tell me, how many dependent variables do we have here? 2. They're the x and y. How many independent variables do we have here? 1. T. Only one independent variable. X is a function of t, y is a function of t. T is your independent variable, x and y are either functions or dependent variables. These are ordinary differential equations. Okay? Now, remember we said by type? What was the second thing we said? By order. This is a first order differential equation because your derivative is to the first power. This is a second order differential equation. This is a first order differential equation. Okay? Now, the third part was linearity. This is a linear differential equation. That's a linear differential equation. this is a linear differential equation. Okay? What would it mean to be other than that? If this thing were squared or cubed or 1/2 power or something else, or this thing was squared or cubed to 1/2 power, this was squared or cubed to 1/2 power, or even this was squared or cubed or 1/2 power, that then would be tending toward a nonlinear. These are linear because all of your derivatives are to the first power, including the function itself. Okay. So we were only talking about type, but since they gave such great examples, I showed you, just mentioned to you what we mean by order, first order, second order, first order, and linearity. We'll get to those later. Now, I'll show you what a partial differential equation looks like. Okay, now here you say do the eraser, and what? Okay, then forget that. Okay, then I use my cursor to do this, this, and that. All right. Huh? Okay, yeah. All right. Now, I just want to see what in the world is this thing? It's an eyedropper?
Whenever you have done a color, you can click on that color and it'll select that color for you.
Okay. Okay, I'll go back to the pencil. Okay. Here are some partial differential equations. Have you ever seen this before? Probably not. Those are twos. But what makes it a partial is that's not a D, it's a squiggly thing.
Oh, squiggly.
Okay, so when you see that, you're talking about partial derivatives. And here's the only time you have, this is what makes that a partial. Okay, what are your dependent variables? You and only you. Just you. No, never mind. Okay. What's your independent variables? X's and Y are both independent variables. Therefore, you've got a function U, dependent, that depends on two independent variables. Then when you can't take a derivative of that, you take a partial derivative. We'll hit that in Cal 3. Don't sweat it now at all. Okay. Now, what we've been using here is the Leibniz notation, or Leibniz, however you choose to say that. Okay? And that notation is the, now that I've written them, I can't unwrite them. Okay? Yuck. Okay. All right. dy dx, d2y, dx squared, d3y, dx cubed. That's Leibniz notation. They also have what they call, and you mentioned this earlier, the prime notation. This would be y prime, y double prime, y triple prime. That sure is a lot easier to write, okay? So I was starting to mention that earlier, but I thought, let's not yet because I don't want to confuse the issue, but that's another way. These would be ordinary differential equations. You don't do partials with that notation. You can't. You have to do the crooked D, for that one. Okay. Then they hit what I've been already quizzing you on. When you see d2x dt squared plus 16x equals 0. What kind of equation is that? That's an x. I don't know what it looks like, but that's an x. Goodness, you have to really bear down on that to get it to. Okay. All right. What kind of equation is that? It's a differential equation. What type? Not very special. It's just ordinary. It's ordinary. The type is ordinary. The order is second order. Okay. All right. What's your independent variable? T. Dependent variable? X, and also that's your function. X. Okay. Got it. All right. Now, there is another kind, and that was Newton's dot notation. And I'm not even going into that, but it's a single dot is like a single prime. And they say there's a derogatory referred to as the Fly-spec notation. I don't know. But usually that's reserved to respect to T. Okay? You most of the time will not see anyone use it except with respect to time. Is that someone trying to get in? What's that? It's what? Oh, okay. All right. Now, when you do in the partials, there is another notation for that, but we're not doing that. Partial of, let's see, which one do they use here? U, second partial of U with respect to x squared. You could write that as u sub xx. Okay, so don't worry about that. That's a different notation, but we're not going to do partials. Okay. So now let's go to classification by orders. I've already introduced this to you, so it's so bizarre. Do this and that and that. Okay. d2y dx squared plus 5 dy dx cubed minus 4y is equal to e to the x. Okay? What can you tell me about that equation? It's what? It's a differential equation. These are derivatives. There's an equal sign. It's a differential equation. Got it.
It's not linear.
It's not a linear equation. You're right. Non-linear. Okay? Next.
As far as the order goes, it's
Second order, because the derivative is in the second order. And it's ordinary. It's not partial. So yeah, very good. Okay. This is a second order term. That's a first order derivative, even though it's raised to the third power. So the third power means it's not linear, but it's still a...
F prime Q.
Yes, exactly. Exactly. Okay? And that's just your function. Okay? Now, here's another symbolic, let's see. Okay, how are we doing? Okay.
Also, for anybody who was looking to rent this punch day, you can rent it for $33. That's pretty good. Or you can buy it for like $170.
What, this book?
Yeah, you can rent it for like 30.
Okay. Was this the one you were telling me was so expensive yesterday?
No, it was linear algebra.
Linear algebra.
I gotta look into that one again.
Okay. This is the same book it's called. Now, you might wonder, why did I choose this book? Well, I had looked at several, and some of them were so involved. In fact, one that I taught from one time went into partial differential equations. I said, this is way beyond what this book should be, what this course should be. But they had to buy this big book that we didn't use half of it. So this is a much smaller book. It's just ordinary, pretty much. But the other thing is, when I looked at this, I sort of liked it. It seemed like it covered everything we needed. Then I went to one of our meetings. I don't remember which one it was, Alamatic or some meeting that we went to. I went to a woman who talked about applying differential equations and, doing some. She was on the NASA grant at Tuscaloosa, at Shelton, which is strange, but she had it, and they were actually doing differential equations, with some real things. And I said, what text do you use? And she said ZIL. So that's why I went with ZIL. I liked it to begin with. I don't like Brooks Gold Cengage, but this was the best book I found for what we need. Okay, because it says the first course in differential equations, and that's really all this is designed to be. I got the light there now. I can't see. All right. Now, remember when I said what comes to my mind when I think differential? Here is actually another way to write a differential equation. Yeah.
Where I rent my books and stuff, it's $70 to rent, but $100 to buy. So
$100 to buy and $70 to rent?
That's might as well buy it.
Yeah. Strange.
There may be a better place.
All right. This is another example of a differential equation back in the form when I said this is what I think of when I think differential. But a differential equation that all these are. And you'll see these later in a certain context. M of xy dx plus n of xy dy is equal to 0. Okay? Now, what's that?
That's supposed to be like points.
Point?
X, Y.
Yeah, that's what it is. But here you specify ahead of time which one of these is dependent and which is independent. Okay? When you only have two functions, no other function there, and even sometimes with 3, but let's not go there. Let's just stay with 2. One of these is a function of the other, just about always. Most of the time, y is a function of x. That's how we usually do it. But it could be the other way. But this would be an ordinary differential equation. It looks like this would be partial because this is a function of 2 variables, but only one of them is independent. Okay? But you can't tell in writing this way which one is your independent. Okay? But here we assume y is the dependent variable and x is the independent. Okay? I'll give the one they do because y'all don't have the book, so I'm writing probably too much today. But here's y minus x. There's your m dx plus 4x. That's your n. It doesn't have y dependent, but it could have had dy is equal to 0. Okay, that's a differential equation written in this form. To me, this is a differential form rather than a derivative form. Okay, now if you assume that the y is the dependent variable, x is the independent, then you can do this. You can. Mathematicians don't like you saying it this way, but here's what you do. Yeah, you're not dividing. Okay. If you thought of it that way, then this would be y minus x, and dx is 1. Minus 4x dy dx is equal to 0. So you could say 4x dy dx is equal to y minus x. Okay. Now that looks like an ordinary differential equation. It's so much better when your when your eraser erased the whole mark. Not, yeah.
Oh yeah, when you just touch it and the whole thing goes away.
Yeah, and yeah, then this could be written as 4x y prime is equal to y minus x, or 4x. They got it wrong here. Sorry about this. Y prime oh no. They've got it wrong. I'm not even going to mess with it. Okay. Here's another way, and this to me is not a very user-friendly way of doing it, but there are times, especially when you're proving things, okay, that you do this. In symbols, we can express an nth order ordinary differential equation in one dependent variable. That would be, say, your y, such as this. F of x, your independent variable, y, your dependent variable, y prime, the first derivative of that, and then go up as far as you want to y to the nth. Now that doesn't mean, yeah, that's to the n, or yeah, prime, n primes, yeah, that you might want to call it. The nth order derivative, okay, is equal to 0, okay? That would be a ordinary differential equation because all of these are ordinary derivatives, okay? There's nothing that tells you whether this is linear or not, so you can't really say anything about that. But
Series or whatever.
what's that?
Isn't that like a series? Towards the end count too.
Like infinite series?
Yeah, that sort of thing.
It could be, but it wouldn't have to be. This is just any equation that you can set equals 0, because frankly, you can pull anything that's on this side over here, subtract it from both sides, make it equal to 0, and then you have some function of x, some function of y, the dependent variable, and then some function of all your various derivatives that you have that are pertinent to the thing. That's one way you can write it. Okay, where f is a real valued function of n plus 2 variables. Okay, one independent variable, one dependent variable, and n derivatives of that dependent variable. Okay, so that makes n plus 2 variables. Okay,
And this class will end at 10:45.
10:45. Right. Okay, so we're getting close.
4 minutes.
Yeah, 4 minutes. All right. Here's the differential equation. D to the nth derivative of y with respect to x in time. Yeah, that's how we write the nth derivative. Is equal to, now I'm not going to call it capital F, call it a little f of x, y, y prime, dot, 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 up to y to the n minus 1. That's the n minus first derivative of y. Okay. Basically, that may be the same thing as this. Doesn't have to be, but it could be if that derivative only showed up with the coefficient 1, nothing else done to it, no powers or anything else, then this would be the same as that. Okay. But of course, that function here could have been doing other things to it, multiplying by 4 pi and dividing and raising it to the third power or the 3/2 power or something like that. But if that was only to the first power, then this would be an This is called the normal form. This one was called the general form. Just names, huh?
The capital F, is that supposed to be like the antiderivative?
No, that's what we used them for before, but that's
Different now.
different now. Whole different place.
Just making sure.
All right, now let's move to classification by linearity. We've already hit it, so hopefully we don't need to spend too long with it. Nth order ordinary differential equation is said to be linear if the capital F here is linear in all of the y's. Notice it doesn't have to be linear in the x's. That could be an x squared, x to the 3 halves, anything. That doesn't. But all of the y's, if all those are to the first power, none of those, including just the y, are squared or cubed or anything other than exponent of 1, then that's nonlinear. That would be linear. Okay? So, a sub n of x, d to the nth, y d x to the nth, plus a to the n minus 1 as a function of x, d to the n minus 1, y dy dx. Yuck. Okay. Get the writing too fast. Okay. Plus plus a 1x dy dx plus a sub 0x y is equal to g of x. Okay, that would be a nth order ordinary differential equation, but this would be linear because all of these are to the first power. All of the y's and the root of 1. These functions of x's, which are your coefficient functions, they can have all sorts of screwy things in them, okay? And the g can be anything, powers, whatever. Now, all we talked about were orders, but actually they could be, this could have an e to the something in it, that could have a log to something in it, it could be a sine or cosine of something. I mean, they could be any kind of functions at all, but this is a linear function in the y's. Not in x's, but in the y's. Okay. And we are out of time. All right, so next time we will begin.
That book is reasonable for renting online. Anybody else looking at that?
Okay, we'll begin there. All right. It will certainly be helpful if y'all have your text as soon as you can. I don't mind going through this much detail, but I don't have to write as much if y'all have it and you can look at it.
Yeah, I'm gonna be ordering that.
Yeah. So get them as soon as you can. I understand. If I were in your boats, I would be doing the same thing.
Especially, since we weren't sure if the class was going to be here or whatever.
All right, we have a 15-minute break, and then 2 of the 3 of you are back here for linear algebra, right?
Yes.
Okay, so good to see you, Victor. Okay. And we'll see you Thursday. Huh?
Tomorrow.
Oh, yeah, wait. You're in
Cal
Cal 3. Yeah. We'll see you to that. But for this course in Thursday, yeah.
They'll just get to see me every day.
Yes.
Except for Friday. That'll be a day away.
Oh, my lucky day. Okay. No. All right, let me end this.